Hello everyone, I hope all are doing good. In the previous class, we have discussed the conversion of NFA to DFA. There are two types of NFA. We have already discussed epsilon NFA and NFA. So in epsilon NFA, there will be at least one epsilon transaction. Epsilon or null transaction also we can say. So what is epsilon transaction? When a machine is on one particular state, let's say Q0, without taking any input, if machine is changing its state from let's say Q0 to Q1, that thing we consider as there is a null transaction. Okay, so let's assume there is a machine like you are having Q0 as initial state and there is a lambda transaction, so I'm representing like epsilon, and without taking any input this machine is reaching to Q1 and let's say Q1 is the final state. Now this machine is defined over a set of alphabet which is taking to input let's say 0 and you are putting a loop let's say 1 here. Now if we are intended to remove this null or epsilon transaction and we want to convert into new NFA only, how we can do that? So what we need to do is first we need to understand what is lambda closure or null closure of any of these states. So if I calculate the epsilon closure of a state let's say Q0, so epsilon closure means if you are at Q0 wherever you can reach without taking any input. So if I am at Q0, obviously without taking any input I can achieve Q0 because I am already there. Okay, and then if I am taking null, there is a null transaction, so that means from Q0 to Q1 also I can move, right? Now similarly you can calculate the null closure of another state, that is Q1. So Q1, obviously every state will be in the null closure of itself, so Q1 will be in the null closure of Q1, but Q1 does not have any lambda transaction, so in the null closure of Q1 there will be Q1 only. Now if we draw the table, let's say I want to draw a new table without any null transaction, so I'm drawing a transaction table here. In this transaction table I'm considering this Q0 as initial and Q1 is final. Remember one thing, when we calculate the closure in any of the state closure, let's say in Q0 there are two states, Q0 and Q1, and Q1 is the final state. That means this Q0 will become final state after removal of this null transaction. So that means in your final automata which you will be drawing, Q0 will also become the final state because in the null closure of Q0 there is Q1 and Q1 is final, right? Okay, so please do remember this. Now after this what we need to do is we start analyzing the things from Q0. So we are intended to write the transaction from Q0 when 0 is coming as input. So first we need to understand without taking 0 wherever Q0 can achieve. So we consider here lambda closure of Q0. Q0 lambda closure will lead us to Q0 as well as Q1, right? So lambda closure will lead us to Q0 and Q1. And now if we pass 0 input here, okay, so the meaning here is because Q0 is having a lambda transaction, so if you are trying to pass 0 input at Q0, it means you are also trying to pass 0 input at Q1, because without taking any input, if Q0 can transit to Q1, that means you need to test 0 input on both. So when you pass here on Q0, there is no there is one transaction for 0, so you will be at Q0, and for 1 there is no transaction, so you will be at 5 null because Q1 doesn't have any transaction for 0. Now you need to also find out the closure of these. What are the possibilities? So Q0 closure will give you Q0 as well as Q1, and this phi closure will give you phi. So that means for 0 from Q0 the union of Q0 Q1 as well as phi will be the resultant states. So it will achieve, or you will achieve Q0 and Q1 from Q0 by taking input as 0. I hope you can understand this. Right? Now for one input from Q0, what we can do? So we are at Q0 and we are taking null closure or epsilon closure. So we are achieving Q0 and Q1 here by taking epsilon closure here. Now we are passing 1 here. So when we pass 1 at Q0, there is no transaction on Q0. When we are passing 1 at Q1, there is a transaction and we are at Q1. Now when you take null closure here and null closure here, you will get phi here and you will get Q1 only here. So that means there is only one transaction, Q1. Similarly for Q1, we can repeat. So for Q1, let us repeat all these steps. So for Q1, we take the null closure and the null closure of Q1 is Q1 only. And if we are passing 0 here, on Q1 there is no transaction for 0. On Q1, if I want to pass input 1, for 1 it is leading us towards Q1 only because there is a self loop. And if you find out the epsilon closure of this or epsilon closure of this will give you phi only and this will give you Q1 only. So that means for 1 from Q1 there is an entry of Q1, but for 0 there is nothing, let's say phi. Now this thing we can convert into the diagram. So Q0 is also final now because in the Q0 closure there was Q1 and Q1 is the final state. So this will also be considered as final, right? Now there is Q1 was already final, so it is still final. And the transaction you write for 0, there is a self loop and there is a transaction from Q0 to Q1. Okay. For Q0, when 1 is coming, it is leading you to Q1. When on Q1, there is no transaction for 0, but there is a self loop for 1. So this is the final diagram. It is still NFA, but this is NFA, not the epsilon NFA. So these are the steps of conversion. If you want to take one more example, we can take quickly. So let's consider there is an automata. Let's say I consider X is one of the state, which is initial. Let's say Y, let's say Z, and let's say W. These are the states, and let's say I am assuming this is the final state. Okay, there are transactions like this, okay, and like this, right? So if you are considering, let's say this is the 0 input, I am considering alphabet is 0, 1. Here I am considering, let's say it is null, okay, and let's say you assume that here there is a transaction. So let's say for 0 there is a transaction and for 1 there is a transaction. So if this is the scenario, right? Now we need to convert this epsilon NFA into NFA. Okay, so we need to remove this null transaction. If we want to remove it, similar step we can follow. So let's consider the closure. So if I consider lambda closure of X, in the lambda closure of X is there and only X will be there. In lambda closure or epsilon closure of Y, there will be Y for sure as well as Z also. In epsilon closure of Z, there is Z and only Z because there is no epsilon transaction. In epsilon closure of W state, there will be W, right? So because W is the final one and it is not occurring in any of the closure like X, Y or Z. So if they were non-final, they will still be non-final. Okay. So in the final diagram, X, Y and Z will be non-final and W is going to be final. Right? Now apart from this, let's say I am intended to draw the table. So let's draw the table. The number of states will be same, so just write the same number of states, x, y, z, and let's say w. This was initial and this is final. Still the same situation is there. Now there is input 0 and there is input 1. Now when we are intended to write these transactions, so what we need to do is we start from a state, let's say we are starting from x. Now from x, first we consider the epsilon closure. So in the epsilon closure of x, there is x only, and on x when we are passing 0, we are reaching y, and in the epsilon closure of y, there is y as well as z. Okay, so for a 0, there will be two transactions, y comma z, for input 0 from y state, or from x state, right, not y. So there will be this and there will be one more transaction when we remove this. Okay, for 1 from x, we again consider the same null closure. So from x, only x we are getting. When 1 we are passing here from x. For x, there is nothing defined for 1. X doesn't take any 1 input, so if you take the epsilon closure of 5, you will be still 5. So there is nothing, no entry for this. It is 5 only. Now from y, if you are taking epsilon of y, you will get y comma z. So I'm writing z here. Now let's say 0 I am considering as input. So from y, when 0 is coming, on y there is no input as 0. On z there is input as 0, so you are reaching y. Now when you are taking null closure of this and null closure of this, you will get phi here, but y will give you y and z. So ultimately y and z we will get when 0 will occur on y. So y as well as z we are getting here. On y, again the same thing. When we calculate here null closure, we are getting y as well as z. We are passing 1 this time. So when we pass 1 on y, y doesn't have any transaction for 1. When we are passing 1 on z, we are having a transaction towards w. We calculate the epsilon closure, so it will give us phi. We calculate the epsilon closure here, w will give us w. That means ultimately for 1 we will get w here. Now for z, if we find out the epsilon closure of z, it is giving you z only, and when we pass 0, it is giving you y, and y epsilon closure of y will give us y as well as z, right? So from z, when 0 is coming, it will lead us to y comma z. Now from z, when we take the epsilon closure of z, it will give us z only. When we are passing 1 here, from z, 1 will lead us w, and the epsilon closure of w will give us w. So there is w for z. Now for w, there is no transaction, neither for 0 nor for 1, so it will be 5, right? Is that okay? So when we draw the diagram, this diagram, when we convert, I again draw it. So I draw, let's say x is the initial, there is no change. This is, let's say, y, this is z, and this is w, and w is the final one. Now from x, y and z, so we can reach y with 0, and we can reach z with 0 input, and for 1 there is phi. From z we can reach y and z, so that means there is a loop for 0, and we can reach z by passing 0 at state y, right? But when y is receiving 1, it is leading us towards w. So like this, So we can reach, by passing 1 we can reach W, right? Now let's discuss Z. So from Z, when 0 is coming, YZ, so there is a self loop for Z and it is leading towards Y also with 0. And on Z, when 1 is coming, it is leading us towards W. So when 1 is coming, it is on W. And for W, there are both the transaction 0 and Y, it's 5, so there is nothing. So this is the final NFA from this epsilon NFA. So I hope this conversion is clear. These two examples will help you to understand this conversion. Thank you everybody. See you in the next class.